Final part of this question now, we have that a function is defined by the parametric equation x equals 4 cos t and y equals 3 sin 2t. Determine the x coordinates of the stationary points. So if x is equal to 4 cos t, we can find dx dt. And dx dt is going to be equal to, when you differentiate cos, you get minus sine. So you get minus 4 sine t, that's dx dt. And then since you get dx dt, we need dy now by dt. Then dy by dt is going to be equal to, when you differentiate sine, you get cos. So that's going to be, you differentiate sine, you get cos, but the derivative of 2 sine 2t is 2 cos 2t. 2 times 3 is 6. And so we get 6 cos 2t. All right, that's dy dt. So now dy by dx is going to be equal to, remember dy by dx is dy by dt times dt dx. So dy by dt times dt dx. All right. So what does that mean for us? In our translation, dy by dx is going to be equal to 6 cosine 2t. So it's 6 cosine 2t divided by 4 sine t. All right. Now, at a stationary point, dy by dx is 0. So always tell them that. So at start point, at a stationary point, we know that dy by dx is equal to 0. So if dy by dx is equal to 0, then that implies that we're solving 6 cos 2t. We're solving 6 cos 2t equal to 0. If we're solving 6 cos 2t equal to 0, then that implies that the cos of 2t is equal to 0. And then if the cos of 2t is equal to 0, then what do? We draw our circle. We know that cos is positive in the first and the fourth quadrant. The cos is positive in the first and the fourth quadrant. And cos inverse of 0 is, cos inverse of 0 is pi by 2. So in the first quadrant, answer will be pi by 2. And in the fourth quadrant, it's 2 pi minus pi by 2, which is 7 pi by 2. All right. All right, 7 pi by 2, is that right? 2 pi minus pi, 2 pi minus pi by 2, that's 4.71, 7 pi divided by 2. Let me write it better. I don't think this says 7 pi by 2. It's 2 pi minus pi by 2. Let me write that better. 2 pi minus pi by 2. And 2 pi minus pi by 2 is, that's 4 pi over 2. This is 3 pi by 2. 3 pi by 2. All right, that's better. It's not 7 pi by 2, it's 3 pi by 2. And so then that implies that t, or 2t rather, because this is 2t, is telling us that 2t is equal to pi by 2, or 2t is equal to 2t is equal to 3 pi by 2. That's what we get here. All right. So now we can divide through by 2. And if we divide through by 2, we're going to divide through by 2. And when we divide through by 2, what we're getting is t is equal to pi by 4. And then we're getting that. We divide through by 2 over here. And we're going to get that t is equal to 3 pi by 4. All right, now that we get t is pi by 4 and 3 pi by 4, now we can find the x values of the stationary point. All you have to do is plug in t as pi by 4 into x. And so we go back up here and put 4 cos t. So 4 cos pi by 4. The cos of pi by 4 is root 2 over 2. And so x is going to be 4 times root 2 over 2. That's one stationary point. And another point is going to be put in 3 pi by 4. 3 pi by 4. 4 cos that is the cos of 3 pi divided by 4. That's minus 4 root 2 over 2. That's minus 4 root 2 over 2. So those are the two x values of the stationary point. Nice and easy, soft. That takes care of question number 1. Nice and easy, soft. All right. Now that we finished question 1, now this kickstarts question number 2. Looking at question number 2, it says a function w is defined as wxy is equal to ln 2x minus ln 2x plus y over x minus 10. Find dw by dx. Dou w by dou x. So we're doing partial derivative. We're differentiating the function with respect to x. So for me, I'm going to rewrite w as ln the modulus of, I'm just going to separate it so it's easier for me to differentiate. I'm separating it as the modulus of 2x plus y, and it's being divided by, so it's minus ln x minus 10. This way it's easier for me. Nice and easy. Now I can differentiate with respect to x easier. So dou w by dou x is going to be equal to, when I differentiate ln, it's going to be 1 over 2x plus y times 2. So it's 1 over 2x plus y times 2. I put a 2 in the numerator. Minus, this can be now minus, when I differentiate x minus 10, it's going to be 1 over x minus 10. All right, nice and easy, soft. That takes care of this question. That's dw by dou x. Now, if you wanted to put it at as one fraction, you could. Maybe you prefer to see it as one fraction. So you could write it as 2 into x minus 10 minus 2x minus y over 2x plus y times x minus 10. This is just to simplify it. If you want, I wouldn't. That's a waste of time. But if you want, you can simplify it. And then in reality, that works out to be minus 20 minus y over 2x plus y times x minus 10. Nice and easy. So that's what we would get. All right, that would be dw or dou w by dou x. All right. Now the next question says integrate e to the 2x sine ex dx. Now first thing I notice I have a e to the 2x here, and I have a e to the 2x and a e to the x. And so to do this integral, what I'm going to do, I like to call the integral I. So let I be equal to, I like to call it I. I is the integral of, I'm going to rewrite e to the 2x as e to the x. This is really e to the x square. This is e to the x square times the sine of, it's like the sine of e to the x dx. Sine of e to the x dx. Now, if I were to do a u substitution, right, I'm going to let, well, I don't want to use u since I might do by parts afterwards. I'm going to let r. I'm going to let r stand for e to the x. I'm going to call it r. R is e to the x. And so if r to the e to the x, then dr is going to be equal to e to the x dx. So what does that mean? That means that this integral I works out now to be equal to this e to the x all square can be written as e to the x times e to the x. That's what e to the x square mean, e to the x times e to the x. Now, this e to the x, now this e to the x dx is going to be dr, and then r is going to be e to the x. So where I have e to the x here and here, that becomes r. So this is going to be working out to be the integral of e to the x is r, e to the x dx is dr, sine, so it's r sine r dr. That's what I'm integrating. All right, so let's do that. Now to do this, we're going to use integration by parts now. So now we're going to let, then you have to think of Eilate rule, Eilate, and you know that algebra comes before trig, using Eilate rule. And so using Eilate rule, we're calling u as r, u is r, and so du is going to be, when you differentiate r, you're getting 1. And then we're calling dv sine r, and so if dv is sine r, when you integrate sine, you get cos, and so v is cosine r, v is just cosine r, and so I is working out to be equal to u times the v, which is r cos r, minus the integral of v du. But the integral of v du, when you integrate cos r, you just get sine r. So it's r cos r minus sine r plus some constant c. And the question finish. Well, not entirely. We have to substitute back for r. Remember, r was e to the x. So the final answer is e to the x cosine, e to the x cosine e to the x minus the sine of e to the x plus c. Nice and easy, soft. So that's how we get this. Nice and easy, soft. All right. Next part of the question, it says let f of x be equal to x squared plus 2x plus 3 over x minus 1 times x squared plus 1, where x is between 2 and 5. It says use trapezium rule with 3 equal intervals to estimate the area bounded by f between the lines y equals 0, x equals 2, and x being 5. So pretty much we're integrating f of x from 2 to 5. So this is what we're finding. We're finding the integral from 2 to 5 of f of x. That's what we're finding, but we're going to be using trapezium rule. Using trapezium rule, the integral from 2 to 5 of f of x, trapezium rule, it's going to be h over 2 into y naught, where y naught is the last y value, y naught plus yn plus 2 times the other y values, plus 2 times your y1, da 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 da. So that's the formula that we use for trapezium rule. So let's go ahead and do this using trapezium rule. What I like to do first is, of course, work out h. H is going to be b minus a, which is 5 minus 2, which is 3, over n. N is 3, so h is 3 over 3, which is 1. So next thing I like to do is create my table. I like to create my table. My table just gives me my values of x and y for the different ordinates. This is x, and this is my y values. When x is, I need to go from, that's going to be from 2, then I go 3, then I go 4, then I go 5. All right, that's what I need to do. Plug in 2. When x is 2, what would I get up here? 2 squared plus 2 times 2 plus 3, that's 11, divided by 2 minus 1 times 2 squared plus 1, and 2 squared is 4, 4 plus 1 is 5. So right here I'm getting y as 2.2. That's for when x is 2. When x is 3, what will I get? I'll get 3 squared plus 2 times 3 plus 3, which is 18, divided by, that's 3 minus 1, times 3 squared is 9 plus 1 is 10. I get 0.9. Then I put in 4. I get 4 squared plus 2 times 4 plus 3 is 27, divided by 3 times 7, 4 squared is 16 plus 1 is 17. I get 0.53. I get 0.53. Then I plug in 5, and I'm getting 5 squared plus 2 times 5 plus 3 is 38, divided by 4 times 26, and I get 0.365. 0.37. And so using trapezium rule to evaluate the area is going to be equal to h over 2. H is 1, so it's 1 over 2 into y naught. y0 is the first y value of 2.2 plus yn, which is plus 0.37 plus 2 times 0.9 plus 0.53. So 0.9 plus 0.53. So when I work this out, that will give me the area. So working this out, I'm going to get, let's put all of this in our calculator. 2.2 plus 0.37 plus 2 times 0.9 plus 0.53 divided by 2, and I get 2.72. So that's the area. I get 2.72. That's what I'm getting using trapezium rule. Nice. Now it says, using partial fraction, show that f of x is 3 over x minus 1